Thank you for joining us today. Welcome to this product masterclass on how to build scalable 3D data workflows. Just a reminder for you all that this session is recorded, so you'll always have the option to watch it back at any time if you need to. My name is David Babushkin. I'm a technical writer here at Encord and therefore in charge of documentation and all of the kinds of technical communication.
Hi everyone, I'm Blake. I'm a product manager at Encord. So I am looking after our physical AI efforts. I've been building machine learning products for the last 8 years. Happy to be with you today.
And also, just a reminder that if you have any questions at all during the course of this session, feel free to drop them in the chat and we'll address them during the Q&A at the end. So let's dig right into it. Let's have a look at our agenda today. This consists of explaining the scale problem associated with 3D data. Next, I'm going to explain how to cope with the scale. Then we will move on to the fragmented tooling problem that many teams have and how to build scalable, iterative 3D workflows. Next, Blake will be giving a live demo of Encord's 3D data capabilities. And as mentioned, we will finish off this whole session with a Q&A at the end. So let's dive in. The scale problem. First, there is an explosion of data volume when thinking about 3D data. A single autonomous vehicle or autonomous driving assistance system can have multiple sensors, LiDAR, radar, and several cameras, all streaming data at once. Each hour of driving can generate terabytes of raw data, and that's before you even start processing or labeling it. Secondly, there's high dimensionality. Each data point isn't just a 2D image, it's spatial and temporal. You're dealing with point clouds, video frames, and object trajectories over time. So we're dealing with a 3D space across multiple frames. As you can imagine, that scales data incredibly quickly. Combining that, with distributed workforces, annotation teams usually have to work across time zones using different tools and often working asynchronously. Causes a problem in itself. And finally, there is heterogeneous data streams, say fusing point clouds with, as mentioned before, cameras, videos, and then coordinating all of that. All of this makes iteration, which means the process of curating, labeling, retraining, evaluating, painfully slow. So given this explosion in data and bottlenecks, it creates a large problem. So how do we cope with scale? There are a few core strategies that make large-scale 3D workflows manageable and, importantly, valuable. First, structure and index your data. Treat your data sets like a product. Make sure it's consistent, versioned, and searchable. When every file, sensor frame, and label has metadata such as environment, weather, sensor setup, you name it, you can actually find and reuse the right data when needed. Secondly, you want to automate labeling and quality control as much as possible. Manual labeling doesn't scale in 3D. Teams are increasingly using like pre-labeling agents or automated labeling techniques. And this shifts human effort from tedious annotation to high-value validation and correction, cutting iteration times drastically. Third, you want to prioritize edge cases. At scale, you don't need to label everything. You need to label what matters. Better data sets over bigger data sets. This means you can use embeddings, clustering, active learning to identify rare and high-impact scenarios that drive model improvements. Curating your data sets in this way means you build smarter data sets and not just bigger ones. Finally, you want to unify your workflows in one place. Most of the friction comes from disconnected systems. One tool for curation, another for labeling, and another for evaluating your model's performance, maybe. Unifying these into a single feedback loop means insights can flow both ways between data and models. And when you do all of this right, the value is clear. Building faster iteration cycles means quicker time to market. Better targeted data sets means higher model performance. And less manual overhead simply means lower operational cost. So that's what scale should look like. Let's look at the tooling challenges a little more that some teams face. So as you can see here, even with the above strategies in mind, most autonomous vehicle teams still struggle because of tooling. The main challenge is fragmented tool chains. As I mentioned before, labeling, quality control, dataset management, evaluation, all happen in different systems quite often. Without the ability to feed model outputs directly into labeling workflows, it's hard to do active learning or continuous improvement. Simple as that. Also, each handoff slows things down and introduces risk. That leads directly to time loss, especially when you have to relabel data due to misalignment between tools or teams. And these relabeling loops don't just waste time, they increase costs and create security and workforce management issues, especially when data passes between multiple vendors. We also have data heterogeneity. While being part of the scale problem, it also causes problems for tools, because combining LiDAR point clouds and camera feeds all into a single tool, sometimes with other data in a cohesive way, that remains one of the hardest problems in this space. So let's have a look at what is required to build scalable and iterative 3D workflows. We have this lovely diagram here. If we take a step back and look at what teams are really trying to optimize for, it usually comes down to these three pillars here: speed, reliability, and scale. In an ideal world, you have all three: fast iteration cycles, reliable data and models, and workflows that scale effortlessly across teams and different geographies. But in practice, most teams are forced to compromise. So let's break it down. When you combine both speed and reliability, you get better model performance. Your teams can iterate quickly and trust the results. When combining speed and scale, you achieve operational efficiency, automating repetitive processes and minimizing bottlenecks as your data volume grows. And when you bring together scale and reliability, that's where enterprise governance comes in, being able to operate at massive scale while maintaining quality, consistency, and compliance. And at the center of all of this is Encord, the platform that brings all these elements together. It enables you to scale confidently, maintain reliability, and move fast without breaking things. So that's the foundation for building sustainable, high-performing 3D data workflows. And how do we do this? Well, we are a data development platform that helps AI teams automate data in a single workflow. This is done through a continuous process of managing and curating your data, annotating your data to produce high-quality labels, and evaluating these labels against your model's performance. So to wrap it up, building scalable 3D workflows isn't just about bigger data sets or faster labeling. It's about unifying automation and iteration into a single coherent system. And that's exactly what we're doing here at Encord, enabling teams to manage, annotate, and evaluate multimodal 3D data at scale, all within one integrated platform. So now over to you, Blake, for the demo.
Great, thanks so much, David. I'm going to do this demo in two parts. So the first part, just before I share my screen, is I'm going to show you how we can explore and curate the data. And then the second part, I'm going to actually show you how we can annotate that data using Encord's tooling. So let me pull my screen up here. So what I'm sharing is an explorer view of our EMM1 dataset. So it's actually something we've just released in the last couple of weeks, which is the world's largest open source multimodal dataset. So it's got over 500,000 files and 1 million annotations. So this is open source and free to use. So you can just go to our website and you'll be able to find this and interact with it. But the reason I'm putting it up here is just to show you an example of how this might look in Encord. So first I'm going to go and filter for the scene data type. So it's going to pull up 3D objects. And then what I'm going to do is find scenes that might be relevant to an autonomous vehicle use case. So for example, I could type in road, or I could type in traffic. So this is just using embeddings that these files have. And then you could then pull up one of these scenes, and you can then interact with it. So you can sort of go around the point cloud and inspect it, or you can go out of it. And then when you're starting to curate, you can use this natural language search capability, or you can search based on a bunch of other criteria that we make available. And you can select various files and add them to a project. And this is a way that we see clients curating and putting, finding edge cases, for example, that they can put into a project. So this is the managing and curation part of the project. So now what I'm going to do is I'm going to move over to a annotation project. So what's happened is there's let's say hundreds or thousands of 3D scenes that have been placed in a project for labeling and review. And now what I'm showing you is my view as an annotator. I've been given a 3D scene and I'm going to be adding annotations, so cuboid segmentations to this 3D scene. So we have our issues panel open. I'm actually going to close this for now. I'm not going to talk about this in the demo, but that's just a nice way to interact with issues that you might come across with the scene itself. I've got my main 3D view, a point cloud view in front of me. I've got my orthographic views, so front, top, and left on my right-hand side here. And then I can see the different cameras that the autonomous vehicle has. So all these pieces of data are tied together as part of the 3D scene. You can see here I can sort of step through the different time steps, and the cameras and the point clouds are changing as part of that. We also have different settings that you can use to help change how the scene itself is displaying and how you can create different annotations. And then we have, for this particular project, it's just a very simple project. We've got 6 different classes on the left-hand side, and so we can add these to the scene itself. So the first thing I'm going to do is I'm going to label a vehicle. So I'm just moving further into the scene just to show you what we have. And you can see here the ego vehicle, where all the cameras and LiDAR and radar sensors are, is here sort of towards the right. And you can see that there's a large, looks like a large truck behind it. So what I want to do is add a cuboid to this truck. So I'm going to use my hotkey for the vehicle class, and I'm going to create the first side and then create the next side. And you can see I've now created a cuboid roughly where that truck is. I can then click on that and I can further refine this this cuboid. So I'm going to go from the left view on my orthographic views, and I'm going to adjust the height of the cuboid. I'm going to adjust the width. I'm going to slightly rotate it just to get that perfectly right. And then you can see there that that track is fitting nicely into the cuboid. Something else I can do is I can deactivate that. I'm only seeing the points in the point cloud at this particular time step. So this is at that particular moment when the radar and the LiDAR had detected what was there. But what I can do, since this is a static object, is I can use all the points that were collected while the ego vehicle was moving through space. And so I can click on this button called Merge Point Cloud View. And what it's going to do is going to take all the points that were accumulated during the scene and display them. And this gives me a much higher level of fidelity. And I can then go back to the track and then I can just make sure that it's correct. So I had overestimated the back of the vehicle. So there I can just do that and refine the annotation. You can also add different attributes to the vehicle, so depending on what kind of information you're capturing, and you can also add very precise adjustments. So it can change the position, size, and orientation of that particular cuboid if you have some very detailed specification that you're trying to apply. The last thing I'm going to show you here is if I wanted to make sure that this cuboid is on different time steps. So I've copied that, and now I've gone to, I'm actually going to turn off the merge point cloud view so you can see the point cloud change as I step through. And let's say I wanted to place the cuboid at a later time step. I can place it there. And you can see here on the left-hand side that it's now at frame 8 and frame 14, but I actually wanted on frame 8 through to 14, not just on the start and end frame there. So what I'm going to do is I'm just going to click that cuboid. I'm going to use a hotkey to trigger our interpolation command. You can access this from the right click as well. And you can see that is now placed in all the frames from 8 through to 14. So that's just a nice way to speed up the annotation across different time steps. So that is cuboids. I'm going to pause there. Oh, right. So I just saw a question here in the chat. So how do you make sure you don't include ground points? So that is a good question. So firstly, you can adjust this cuboid, as I showed you here. But the other thing to keep note of is when we create cuboids, we actually create it by default on the ground level. And the ground level itself, you can visualize the ground level. You can also adjust the ground level. So sometimes scenes aren't perfectly calibrated based on the source data, so that you also have the ability to adjust that. And so that when you are creating cuboids, you're always creating it on the ground by default. And that way you won't include the ground points, you'll just include the vehicle itself. Okay, so now I'm going to move on to segmentations. And so segmentations are quite handy when it's sort of a non-rectangular object, something a bit more complex. And so in this case, I'm going to segment a tree. So I think there's a tree here, just to the left of the ego vehicle. If I turn on the merge point cloud view, you can see that in much higher level of fidelity, but there's just a lot of noise, right? There's just points from all different time steps. And so I want to narrow that noise down. So what I'm going to do is I'm going to use a tool we have called a scene slicer. And what this does is it allows you to basically create a slice of the point clouds and deactivate the points outside of that slice. And then what you can do is you can do intersecting slices. So I've done that from top to bottom. And now what I want to do is do it sort of from front to back. And then we now have this tree nicely isolated. And then what I can do is I can sort of move around, and I'm now going to create a segmentation. Let me just kind of increase the size of that. And I now have that tree segmented, and I can then go out of that slice view, and you can see that it is captured there. I can actually go and erase some points that I didn't want to capture. So those are now gone. And now that that is captured. And if I can turn off the merge point cloud view, you can now see that I have labeled this tree, the points related to this tree on every single time step as I move through the project. So I've now done 39 frames in just with one annotation. So that's just a nice way to accelerate the annotation speed. So that is, I've just shown you cuboids, I've shown segmentations. We also have other types, so you can add points along the ground and polylines, so that can be quite helpful for traffic markings or specific points of interest. So we have various types of objects that can be added, and you can sort of, you can see these, you can sort of easily sort of zoom out and sort of move around and sort of move to different parts of the scene and add objects there. I think the other thing just worth mentioning before I wrap up the demo, I should have actually mentioned earlier, with the adjustment, you can also actually adjust these in the camera view as well. So you can see I'm just adjusting there on the bottom left. And that's also a nice way for you to get a much more refined annotation. So you might be using something visual to help refine the annotation instead of just the point cloud itself. So that's also a very helpful way for annotators to increase their level of accuracy. So I think that's all for me for now. So I'm going to pause there and hand back over to David, and I think we might have some questions.
Lovely. Thanks for that. let me just go back to the presentation. I hope you can all see this. And yeah, this was the demo slide. So yeah, in conclusion, Encore provides all the tools that you need for insight-driven 3D data management workflows. And in the demo that Blake just showed you, he demoed the curation and the annotation parts of this workflow. So in Encore, workflows are unified and automated. So this results in shorter iteration cycles, and this means quicker time to market. Enterprise-grade QA, monitoring, and compliance are essential for building trust in your models. This is something that we provide. And importantly, managing data, teams, and iteration cycles in a single system results in better targeted data sets, which directly leads to higher model performance, and less manual overhead, which means lower operational costs. So yeah, on this note, let's move on to the Q&A, see if there have been any more questions dropped into the chat.
Yes, I think there's maybe I can just take the first one. So from Chloe, she's asked, is it possible to add distance references on the scene? So let me just share my screen again. So it is possible. So we actually do see this used quite frequently. So annotators might be told that they should only label things that are 100 meters away from the ego vehicle, for example. So we have this radius indicator functionality. So you can just add a radius indicator. You can change where you want that to be. So I've just changed it to the ego vehicle. You can just, let's say 100 meters, and then you've now got this radius indicator, and you can just see the exact size reference, and you can know where to label, or where to label more accurately or less accurately. So that is used quite frequently for this type of task. And I think the second question is also, I think we did touch on it earlier, but it is, how do you ensure that the bounding box drawn around the truck vehicle doesn't contain any ground points? So just as I mentioned earlier, when we create a cuboid, it automatically places on the ground, so it doesn't include those ground points below. But the ground itself is adjustable, so you can just visualizing the ground level, but you can actually adjust this ground level for the scene, and then that will dictate exactly where the cuboid gets placed. So that's a nice way to manage that. I don't know if you want to take the other question there, David, or...
Sure. So this is more just a general question about the Encode platform. We mentioned managing multiple teams working in parallel. How does Encode help mitigate bottlenecks with this? So there's a number of layers to a number of ways to answer this. We have role-based access control to our system. This means that depending on what role you log into Encode, whether you're an annotator, reviewer, a team manager, you see different parts of the product and are only shown the parts of the product that are relevant to you. Importantly, it's all one integrated system. So the moment an annotator submits a task, it appears in a review stage, ready for reviewers to look at it. Team managers have oversight over the whole process. They can snoop in, have a look at what the annotators are doing, have a look at what the reviewers are doing at any stage. And finally, project admins. All of these different labeling streams are happening in different projects. Project admins can export data and their labels at any point. They can version their labels. They can see how labels progress over time. So we account for all of these different roles and all of the needs for all of these different roles. I hope this answers your question. Well, if that is it, does anyone else have any questions? Otherwise, we can give back some time.
Yeah, sounds good.
Feedback. Wonderful. Well, thank you for sticking with us. It's been a pleasure having you here, and have a lovely rest of your day or evening.
Thanks, everyone.